section 2 allows us to solve systems algebraically. So yesterday in day 1, we talked about substitution, and today we're going to talk about elimination. Elimination is a method that you can use to use properties of addition or subtraction in order to eliminate a variable in a system. So I know that it says addition or subtraction, but I tend to focus on whatever one comes easier in the order, and I'll show you what I mean by that as we move on. So these questions will specifically say to use elimination. Your goal is to focus on a variable whose coefficient in one equation is the complete opposite but same number in the second equation. So take a look at the y terms here. I have a positive 5y and a negative 5y. If from the very beginning I immediately combine these two equations, plus 5y and minus 5y cancel. Then I'm going to add the rest. 2x and 6x is 8x. 17 plus a negative 9 is a positive 8. And if I divide both sides by 8, I get x equals 1. Now you can put that x equals 1 anywhere you want. I'm actually going to take that x equals 1 and put it in the top equation for x. Either equation would work, but I chose the top mostly because the numbers are positive. So in the top equation, it's 2 times x, which is 1, plus 5y equals 17. And then use algebraic operations to solve. 2 times 1 is 2, plus 5y equals 17. Subtract 2 from both sides. Get 5y equals 15. And dividing by 5 gives me y equals 3. Written as an ordered pair, if you would prefer, would be 1, 3. X is 1, y is 3. That makes this an independent, consistent system. That's not being asked of you, but that's something we've discussed already. It's independent and consistent because it has one answer. So letter B, this one's not quite as straightforward as the last one because none of the variables will cancel right away. But take a look at the y terms. I have a positive 15y, and then I have a negative 5y. If I could take that negative 5y and multiply it by a 3, just pause for a second, I'll explain why in a second. I'm going to recopy what I have. The top equation will not change. But the bottom equation, everybody by 3, gives me 21x minus 15y equals 51. It's that minus 15y that I was looking for. Because now, when I combine these two equations, they cancel. Negative 2x plus 21x is 19x. And negative 32 plus 51 is 19. I divide both sides by 19. I get x equals 1. This problem is a little different than the last one because I can take that x equals 1 and put it into any of the equations. There are technically 3 of them. I'm just going to choose to put it in this top equation for x. So negative 2 times 1 plus 15y equals negative 32. The choice is completely yours. I tend to pick the top equation unless one of them looks significantly easier than the other. So solving, I get negative 2 plus 15y equals negative 32. Add 2 to both sides. Gives me 15y equals negative 30. And dividing by 15 gives me y equals negative 2. This one also ends up being an independent, consistent system because it has an answer. 1 to be exact. Pause the video, complete the U-Try-Its, and then come back to check it. You should have found in this one that when you eliminated the options, you ended up getting a lot of elimination going on. What happens is your x's cancel and your y's cancel, but so do your constants on the right. You get 0 equals 0, and that's a true statement, which makes it infinitely many solutions. Had it been a false statement, it would have been no solution. But this one happens to be dependent. If I graphed them, they would be the same exact line. So here, things are going to get a lot trickier than what we're used to. If you take a look at letter E, they want the solution to the system and they want us to use elimination. So when you look at them, neither of those variables are more advantageous than the other. So I'm actually just going to choose the y variables because whatever choice you want. And in order to get them to cancel, one's positive and one's negative already, I'm going to take the top equation and multiply it by 2. So my new top equation becomes negative 6x plus 2y equals 10. My bottom equation is 6x minus 2y equals 10. All right, so my x terms cancel and my y terms cancel, so I'm left with nothing on the left. But on the right, be really careful. They don't cancel. I get 20. And 0 does not equal 20, so this is a no solution. Had I graphed them, these would be parallel. They're an inconsistent system. Pause the video to do the try.